Hedonic pricing is the final chapter in the series on using revealed preference methods to value the environment. You're looking at a house in Dorchester. The basic thought behind hedonic pricing is that any market good, the price of any market good is a function of its characteristics. So a house that has more bedrooms or more bathrooms would sell for a higher price. The house that is in a better state of repair would sell for a higher price. And you can't buy these things separately, you buy them as a bundle. Now the basic thought behind using this method for environmental valuation is that it's not just the qualities of the house, but also the qualities of its neighborhood that matter. So houses that sit in an area where the schools are good would command a higher price. But also houses that sit in an area that is very noisy, because it's near an airport, for instance, would go for a lower price because people don't like that. Houses that sit near water typically command a higher price, and also houses that sit near nice parks typically command a higher price. Now what you would like to do is find the value of an environmental good from the price differential that it induces in an otherwise identical house. So the ideal situation would be where you will have two houses that are identical in every sense except for, say, noise. If noise is what you want to value, then you would want to find two identical houses, one with a lot of noise in the neighborhood and one with little noise in the neighborhood, and then you have the value of noise. The problem is that houses are not built in random places. Typically you find nicer houses in nicer spots. So what you need to do is run a regression. You need to collect a lot of data, where on the left hand side you have the sale price of the house, or sometimes you don't have the sale price, but you have the asking price. And on the right hand side you have all those things that matter for the value of the house. How big it is, how many rooms it has a garage, and so on and so forth. Characteristics of the neighborhood, crime rates. Is it a young neighborhood or an old neighborhood? Are there schools nearby, good or bad? Of course, the condition of the house. Is it near a bus stop? Is it near a shopping center? And so on and so forth. All these things matter. But what also matters, and that's what we're interested in here, is how noisy is it? Is the air quality any good? Is there nice water nearby? Are there scenic views? And so on and so forth. And the idea is that you collect data on all these things and then run a regression of the sale price on all the things that you think might matter for the value of a house and for which you have data. Typically, or oftentimes nowadays, you would use GIS data for that. So you see here 4 maps of London. This is road noise. You see the major arteries, and the darker the color, the noisier it is. This is airport noise, which is of course much more localized. This is Heathrow, right? This is air quality, and the darker blue is better, but in the city center air quality is pretty bad. And then these are all sorts of environmental amenities. So blue is water, you see the Thames here. Green are parks, and then the black things are just houses, and that matters too. And you can do 2 things here. One, you can just estimate the hedonic price function. That is what I just described. And then what you recover from that are the implicit prices of the characteristics. If air quality goes down by 7%, and the house price goes down by £10,000 or something. And this is relatively straightforward to do. The problem here is that you estimate a very local approximation, and essentially you can use this to find the value of small changes in environmental quality. If you want to look at larger changes in environmental quality, then you need much more variation in your data. One, and that makes it just harder to do because the data requirements are much more stringent. Because if you want to estimate the effect of a big change in something, you need a lot of data that show these big changes. But also then you typically get into the situation where you're not modeling a cross-section, not a snapshot of the housing market, but you actually have data of the housing market as it develops over time. And then your model also needs to include the dynamics of the housing market. And those are typically quite complicated. So this is relatively straightforward to do for small changes in the environment, but much harder to do for non-marginal environmental changes. And therefore it's not often done. But the basic idea is that you estimate the demand curve for environmental quality as expressed through housing. This is what an equation could look like. I actually don't know where this particular study is situated, but essentially on the left-hand side you have the log of the house price, and it's given in dollars, so it must be somewhere in the US. And then on the right-hand side, you have all the things that you think might matter. The age of the house, the area of the house, the bathroom, does it have a pool? Only probably in California or something. Number of fireplaces, so this is a pretty rich neighborhood. The crime rate, school quality, and all these things, as you can see, because these are T-stats. Yes, these are T-stats in brackets. All these things matter. We are in the US, so ethnicity matters, and the whiter the neighborhood, the higher the house price. The density of the housing, is it an urban area or a suburban area or a rural area? The distance to the beach, and this is a negative sign, so the further away you are from the beach, the lower the price of your house. Distance to employment center matters, but then also air quality. And air quality is measured in two ways. One is total suspended particles, no, total solid particles, sorry, and we're talking about air quality. Or NO2, nitrogen dioxide. And what you see in this is in log, and this is in log. So a 1% increase in the concentration of nitrogen dioxide reduces the house price by 22%. Right? This is what this equation is telling you, and it's also highly significant, right? So yes, environmental quality matters, and it matters in this case quite a lot. So that is essentially what hedonic pricing does in a nutshell. There's a number of assumptions that go into this, some more credible than others. Essentially, you're looking at the demand for something that is not traded by looking at another market, and that only works if that market is indeed working well. So strictly, you need to assume that every potential house buyer has a lot of information on the market, that transaction costs are low or irrelevant to the price of the house, that the market is in equilibrium, and so on and so forth. Now, if you make these assumptions, then it follows that the equation that you have here only has the structural characteristics of the house and its environment and the neighborhood. And that is because if the market is in equilibrium and there's a large number of potential buyers, then it does the characteristics of the buyer do not matter because they are in competition. And what you're measuring is the best response in the NAS sense of the word to the market condition. If the market is not in equilibrium, then of course, or there's market power, then of course it is the case that a particular buyer and the peculiarities of that buyer or a particular seller and the peculiarities of that seller would show up in the equation, but not if the market is in a perfect equilibrium. So that is an assumption that you make, and of course another assumption that you need to make is, does the log of the house price depend on the log of air quality? Does the log of the house price depend on school quality? Not logs, but the log of the crime, right? So the functional form actually matters, but that is one that can be tested with the data that you have. Good thing about hedonic pricing is that property records are available from many, many places, and often in the public domain. So that is good. There's typically a lot of data. The data is reliably recorded because the sums are so large that people actually make sure that it's properly recorded. And property markets tend to respond to anything that goes on in their environment. So those are good things. Negative things about hedonic pricing or weaknesses of the hedonic pricing method is that you can only value those things that matter to house buyers. So those are again direct use values. And you may sort of say, well, you may sort of argue, well, perhaps it can measure bequest values as well because people want to leave their house for their children, but that is actually pretty rare. If a house is left to the children or the grandchildren, then typically the first thing they do is put it on the market for sale. So what matters there is the resale value rather than anything else particular in that house. So it's you measure the direct use value to the potential buyers if the children put the house on the market. Another important weakness of hedonic pricing is that the things that you can measure are only the things that the market knows about. So if there's a house with a flood risk that is undisclosed and there are no public records of what the flood risk is in a particular area, then that would not be picked up by the housing market because the potential buyers do not know these things. That is nowadays not the case for flood risks in the UK because there's mandatory reporting on this, but there's no mandatory reporting on air quality. And you could therefore reasonably assume that the housing market in the UK reflects flood risks, but assuming that it reflects air quality is actually a tall assumption in this case because people do not know air quality, and the real estate agent does not disclose air quality typically, and that therefore means that you cannot assume that the buyer knows, and therefore it is not reflected in the price. Another big weakness is that the environment does not just affect house prices, but it affects wages too. And that may sound a little bit far-fetched at first, but just imagine a scenario where you are offered a job right? And the job is in Paris, and you think, yoo-hoo, I can't wait to tell the people at home that we're going to Paris, right? And you would eagerly accept that particular job. It could also be that your boss calls you into the office and says, sorry, you will have to move to Murmansk. And then you will be hard pressed to say to sell that to the people at home that they're gonna have to spend time in Murmansk, which is a pretty desolate place with a pretty awful climate. So yeah, the first offer, go to Paris, you would happily accept. And you may even take a pay cut to move to Paris. And I know people who have taken a pay cut to move to Paris. But if your boss sends you to Murmansk, the question that may pop up in your mind immediately, so how much extra are you going to pay me to live in that god-awful place? So environmental characteristics, and it's not just a natural environment, but it's crime rate and so on and so forth, and all the things that come with living in Russia. If you're gay, for instance, that you would not want to live in Russia. That affects wage rates too. And the reason that I say this, well, on the one hand, you may think this is great. We can also do hedonic pricing on the labor market, which is true. You can, and it has been done. The problem here is that the labor market and the housing market are very strongly connected to each other, because the largest expenditure in the typical household is either on rent or on the mortgage. So house prices affect wages, and if houses are expensive, you would demand a higher wage. And of course, if wages are higher, then people are bidding up the scarce resource that is houses in a place. So house prices affect wages, and wages affect house prices, and both are affected by the environmental characteristics, the neighborhood characteristics, which immediately implies that you have an econometric problem of identification here, and you need some sort of simultaneous equation and solve that. So that is a technical problem. It's not insurmountable, but it makes it a lot harder to do this right. Let's look at a particular case study of hedonic pricing as done by Gibbons in 2011, and the situation here is in the UK, and the question is, what is the value of living in or near desirable natural areas? And those natural areas can be used for a whole range of things. They can look nice, you can go running or cycling there. You may use it to teach your children biology and so on and so forth. There's all sorts of potential benefits of living near a natural area. The study used 1 million housing transactions, and actually they looked at the mortgage market. That's where the data came from, which is an immediate drawback, because there's a particular segment of the housing market that is not bought through with a mortgage, right? Good thing about a mortgage is that the mortgage market is that you actually have a lot of data, and a lot of reliable data. The bad thing is that at the very bottom of the housing market, you don't get in the very top the Russian oligarchs who buy a house in cash. You don't get that part of the market either. You have characteristics of the house, have characteristics of the neighborhood, and you have characteristics of the environment. And this is the sort of stuff that they put in. This is a map of the United Kingdom, and this tells you what is what. So green is grass, and brown are cereals, it's agricultural land, blue is water, and so on and so forth. And you get an idea of what is where. Also, where are the national parks? South Downs National Park is here. This is the University of Sussex. whereas designated greenbelt areas, national trust properties, all those things are just known and can just be plugged into the regression. And they ran that regression, so 1 million observations of sale prices and all these areas that you see. So, if you live in an area, if in the circle around your house, the amount of fresh water increases by 1%, then the price of your house goes up by £768. And if there's more woodland, broadleaf woodland, then the price of your house goes up by 377. But people don't like coniferous woods that much. They really like domestic gardens. That's not just because they like the sight of domestic gardens, but having domestic gardens also tells you something about the neighborhood, of course. But yeah, these things matter. Not a lot, right? £1,000 is not a lot on the price of a house, but they do matter a little bit. And of course, we're also here talking about a relatively small increase in the area. Living or a house within a national park is worth a lot more. A house in the greenbelt is also worth a lot more. So these things pop up, and this again has a negative sign, but it's the distance to a national trust property. So the further away you are from, say, Sheffield Park, the lower the price of your house, right? So this all makes perfect sense. And then you can put all these environmental characteristics together, and then you get a map like this. And the way to read this is that the dark green areas are the areas where the housing market thinks that the natural environment is best. And that actually can add up. That adds up to almost £70,000 on the average house, and that is in the Lake District, obviously, and Exmoor and Dartmoor, where people really like the environment. And this is not what the environment is like, but this is how people who buy houses appreciate the environment. And then the red is the areas where people really think that the environment stinks. And the lowest point is somewhere near Northampton. So this can be done, and it gives you an idea, and in this case it is a very sensible result. This is what you would expect the result to be. Qualitatively, the good thing about this method